Okay, so now we're going to start extending what we've spent this last week doing with the paper slide with the graphs, the paper strip graphs, and you already know that the cosine, when you're graphing a cosine, that starts up at whatever y equals 1, as far as you know now, and then it starts heading down, and then at pi over 2 it's 0. At pi over 2 is 0. Then at pi it's -1. Then it's coming back up. At 3 pi over 2 is back to 0, and then at 2 pi it's back up to 1, back at 0, right? And then it goes reverse too. Down to 0, then down to -1, then back up. Okay, so that's old hat. So for this one, it's being stretched. And remember how we had that discussion about how the diameter of the can makes the graph go higher? Well, the way you can tell that from an equation is just look at that number in the front. And that's called the amplitude, okay? And so this one has an amplitude of 7. If I had to make a graph of this, it would look just like this one, but instead of only going at 1, it would go all the way up at 7. And we can kind of cheat and call that 7. But really, to see a good scale of it, we're going to come out 4 lines, because those are the turning points, right? And we go up 1, 2, 3, 4, 5, 6, 7, and down 1, 2, 3, 4, 5, 6, 7. And then cosine starts up at 1, and then down. It just looks like a stretch. It's the vertical stretch. And there's one cycle, we call it. We could do 2 cycles. And I should be graphing the points, because that's gives you a better graph. Okay. So the amplitude is the number that's in front of the sine or the cosine. And it's really easy. It's just the vertical stretch. Something else we didn't see with the paper slide graphs are these midlines and how the graph is shifted up or down. And as you can see in this set of directions from section 6.1 in the book, is the midline you can tell is just by looking at that last number, and that's basically the up-down shift that we've looked at before. So this is a midline of 4. And if we were to graph that, actually they don't want us to graph that. Let's graph this one, because there's a feature about the top one that I don't want to talk about yet. So they got to graph it. Well, we know the midline is the line y equals -4. I know the amplitude is 3. So I'm going to make myself a little quick sketch here. And I'm going to come 4 lines this way for the 4 turning points, 4 lines this way. I'm going to go down 4. Let's see if I can't move that whole thing up. Oh, I can. Good. So I'm going to come down 4. And this is the midline. I'm going to put a dotted horizontal line just for us to work with. And then I'm going to come down with 3 lines below that. And I'm hopefully asking yourself, why did I go 3 lines below that y equals 4 line? Well, you see how the amplitude is 3? That means I've got to start, and not just going 1 above or 1 below. I've got to go up 3. So since 3 cosine x just starts up at +3 and then heads down, we're going to count 3 spaces above our midline line of y equals -4. And that's where I start my graph. And then it zeroes out at the first turning point, right? Remember, this is the first turning point, so I'm just transferring all those down here to my midline. Then I'm down, all the way down to the bottom at pi, and that's, remember, because the amplitude is 3, I'm coming down 3. Then I'm back to 0, and I'm back to 1. So here's one period of that graph. Notice I'm putting a nice smooth sine curve, or cosine curve actually in this case through this, not a V, that's what we're kind of looking for. So that's one cycle of that graph. If I want to do more, I could come back this way. Here, let me go to blue ink. I'm coming down to -pi/4. I'm coming down to -3, because that's of our amplitude at pi over, sorry, this should be pi over 2, pi, 3 pi over 2, -3 pi over 2, back up at -2 pi. So there's 2 cycles of that graph. What's so different about that one? I don't know if you can see it anymore, but if we go back up, yeah, what's so different about this graph? What does that have a midline of? Actually, I'm not going to have enough space to draw that right there. Whoops. That's going to have a midline of what? I hope you said positive 4. So 1, 2, 3, 4. There's my dotted line. And then I got to go, remember to go up 3 because of my amplitude. I'm going to cheat a little bit. But then what's different about this is there's that vertical reflection. It's a reflection around the x-axis, or in this case, around the line y equals 4. So just like what you've done on other graphs and other kinds of functions, instead of starting up here at positive 3, we're going to start down here, or at positive, what is that, positive 7. We're going to come down 3 from our midline and start there. And if we draw 4 lines, you zero out, you max out, you zero out again, and you back down. Okay, so that's just a reflected cosine graph because the amplitude is negative, but actually the amplitude is still 3. It's just been reflected. So don't tell me the amplitude is negative 3. Tell me the amplitude's 3, and it's been reflected. So now the next twist is the period, and this is kind of this is a horizontal compression or horizontal stretch. And the way we do that, just like what we did in class when we did those paper strips graphs, we know that the normal period for the sine and the cosine function is 2 pi. To see how much it compresses, we're going to divide that number by our b, and the b is this number right there in the inside with the variable, and that's our period. And that's how long it takes to repeat. So we're going to take 2 pi and divide that by pi over 6. Well, thinking about some fractions, 2 pi over 1 times 6 over pi. Remember, we're going to flip and multiply. Take the reciprocal of the divisor and multiply. Then what cancels out here? Let's see. The pi's cancel out and nothing else. That tells me the period is 12. So it takes 12 units to stretch to make one full cycle. So this is a very elongated sine graph, and this is real life applications. This are like infrared. You know how infrared light waves, you might have studied some of that. You will in physics if you haven't yet. They're a very long wavelength, a very stretched out kind of graph if they look at them, versus ultraviolet is very short, so they have a much shrunk up period. Okay, but that's how you calculate it. So remember, 2 pi over b will tell me my period. And when we look at writing the equation from a graph, you'll learn how to do the reverse of that. Okay, so now comes another thing in our toolkit. We know the amplitude's 3, so that's easy. And we're seeing the b number. I'm hoping you recognize that b is the pi over 4. So because it's the number in front of the variable. So let's find the period of this graph. So it's a sine graph, so 2 pi divided by pi over 4 becomes 2 pi over 1 times 4 over pi. Pi's cancel out. That gives me a period of 8. And then the left-right shift is what's coming into the play here. And remember how I wrote on the board in class, f of t would be a sine b times t minus h plus k. If we have this written this way, I can see the left-right shift written very easy. This isn't written this way, so I want to make that inside the parentheses look like this. And the way you do that is factor out a greatest common factor. So the greatest common factor for pi over 4t and negative pi over 4 is pi over 4. And of course we already knew that was our b. And then if you're dividing each of those by pi over 4, that gives me 1t minus 1. Plus 0, and it's the sine, and it's 3. So this function has been shifted to the right one. It has a period of 8. It has an amplitude of 3, and it has no midline. It's not been shifted up or down, so it's on right around the y-axis. So let's see if we can't move this up and do some more work with this. So I'm going to draw a graph. I'm going to start with just one period of it. Now here's the tricky part. I could draw out to 12. And that would be a nice scaled model of this graph. But since we just want to make up a rough sketch of this to get a general shape, I know that this is going to be 12 because that's the period. That's how long it takes to get to that point. Half of it is halfway around the circle, which would be 6. Half of that would be 3. And then what I'm going to do is I'm just going to add that. So 3 plus 3 is 6, plus 3 is 9. It has an amplitude of 3. So 1, 2, 3, 1, 2, 3. It's been shifted to the right 1. So let's mark that there. And then what I'm going to do is mark another little line right after they represent that it's been shifted 1 to the right. Now, before I do that, let's pretend I am just graphing 3 sine of pi over 4t. That would look like this. That would look like I would start at the x-axis, because sine of 0 is 0, right? The first turning point's a maximum. That's like pi over 2. In this case, though, it's 3. Then I'm going to come back down to 0. I'm going to come back down, all the way down to where it bottoms out. That's like at 3/4 of the way around the circle. And then it's back at that. So that would be that graph. Now, if I want to go back up and graph this now, all I'm going to do is I'm going to take this function that I just graphed. Let's see if I can do that. And I'm going to slide, nope, it's not letting me. I'm going to slide that all to the right 1. So let me go with a blue ink. So instead of at 0, 0, I'm going to do that at 1, 0. I'm going to max out right there. Notice how I'm right over the 1, where I shifted it over 1. So that's not really 1, that's at 4 actually. Then I'm going to come back down to the next red line that I shifted to the right. I'm going to put that there, and there's 1 cycle of that original graph. Okay. So here we go. We have got to figure out the amplitude. Well, I'm hoping by now you know the amplitude is just 3, that number right in front. The midline, well, then we look at that last number. So it's 1, so it's the line y equals 1. Now we need to get the period. So the period is going to be, remember, the normal period for sine is 2 pi. We're going to divide that by 2. So that gives me a period of pi. And there's no left-right shift because there's nothing inside the parentheses. So if I had to graph this isn't asking us to do that, but let's do it anyways. Give you a little practice with this. Let's see, I'm not shifted left or right, so I'm going to put that line in the middle. My amplitude is 3, so I'm going to go up 3, down 3. I'm going to put 4 lines to the right, 4 lines to the left. I know that last line is pi, because that's the period. Half of that would be pi over 2. Half of that would be pi over 4. So remember, all I'm really doing is multiplying each of these by half. So 1/4 pi, 1/4 pi, 2/4 pi, 3/4 pi would be that last number. Now I'm going to go down here and just make them negative. Negative pi. And I've got to shift this whole thing up 1 line, don't I? Because the midline is y equals 1. You probably already was wondering why I did that, why I missed that. So I'm going to stick another 1 up there, so I've got 3 lines going up. So now let's see, cosine, no, we're talking about sine. So sine starts at the midline. Then we're going to, now it's not reflected, so we're going to max out there, back down to the midline, then we're going to count down 3 lines, so we're not down to the 3, we're going to be down to the -2, then back up, and then we're just going to go in the reverse, down 3, back to the midline, up 3, back to the midline, and let's fill that in. Okay, so that's how you put it all together and make a graph. Now they're making us write a formula. So I know when I'm done, I'm going to have y equals a times, let's see. They aren't telling us whether it's sine or cosine, so I guess maybe what we should do is just do a little graphing here, because I have a feeling it's going to be both. It could be either one, I mean. All right, so the midline is, the sinusoidal function starts on the midline at a point of 0,3. It has an amplitude of 2 and a period of 4. So to me, I know that starts there. They're telling me that's the midline. They're telling me, so I know there's going to be a plus 3 at the end. It has an amplitude of 2. They also tell me, oh, here's the trick. They're telling me to start on the midline. So since I'm starting on the midline, I know this is a sine graph. It's also not shifted left or right because it starts on that 0,3. So I guess the next trick is, I'm going to draw my 4 lines. It has a period of 4. So since it takes 4 units to get over there, to get that b number, so this is, remember where we talked about if I write pi over b gives me the period? Well, if we pretend this is a proportion and cross multiply, won't 2 pi divided by the period also tell me b? So 2 pi divided by 4 is pi over 2. So that's the number we're going to stick in front of that. We need a sine. We need a plus 3. Now what's the amplitude? 2. We know the amplitude goes right in front. So that is an equation that models this situation. So we reviewed about finding, so what was a little new about this is finding b if I knew the period. We had to decide the midline whether it was shifted up or down, and then was it sine or cosine? Okay, well I hope that helps. So I was going to record a video for these, but I think what I'm going to do is you have the odd answers for these odd exercises. They're in the back of the textbook. They're also online. What I'm going to do is I'm going to write up a sheet of paper and put these online, put 12, 14, and 16, the answers online. So you don't have to watch any more video for this part.